So here I'm going to explain how we can do regression analysis in the Python. Here I'm going to use Colab, and later on I will show you how to do it in Jupyter Notebook as well. The file that we are working on is age versus salary. The file is uploaded for you, so you can upload it in your area. So just remind you, there are two ways that you can upload the Excel file into your environment. The first way is to basically click table of contents and then files, and simply drag and put your file here. So your Excel file will be there. We need two libraries here to start with. Import NumPy as NP and import pandas as PD. I explained already these two libraries. NumPy is for working with numbers, arrays, and etc. Pandas is for working with data frame. If it's your first time, you need to install it using pip, as I said before. So basically, you need to type pip install NumPy, for example, or pip install pandas. But here we assume that you have installed it already. So we are not going to run these two lines of code. So we import these two libraries to our environment, and then I want to upload the data file. So I'm going to call it df. df is equal to pd. pd is the library or module I'm going to use. pd.readExcel is the function for reading an Excel file. And what I'm going to do is to, click on these three dots and copy path. And then, assuming that I'm going to delete this one right for now, and then paste it here. So I copied the path and paste it here. Remember, I need to put this path inside single quotes. So I put single quotes before and after the path. So, and then I want to see what is inside the df or my data file. I'm going to click on this. You will see that I have got two variables, age and salary, right? 9 observations. Another way to upload the file into your environment is to use or upload it directly from your Drive, Google Drive, right? So in a case that you put your file in the Google Drive, in case of me, I have got a folder named MLAI for finance, and I have this file here. So what I can do basically is to, again, I can download, actually upload this file directly from Google Drive, but I need one step more in advance, which is mounting my Google Colab to the actually Google Drive. In other words, I should connect these two, all right? So there is a line of code from google.colab import drive, and then drive.mount is a function, content drive. So by typing and executing these two lines of code, so I will mount my Google Colab to the Google Drive. I have done it before, that's why it didn't ask me extra steps, but in case that you are doing this for the first time, it might ask you for user and password to connect, and also permissions to connect your Google Colab to the Drive. And then what you need to do is to again, copy and paste the place this file is located in your My Drive. And basically, the next step is to just execute the code, and you will have the same um, data file there. So I already have got data file, so I'm not going to use this approach. So later we wanted to uh, draw a graph which explains or show the relationship between age and income. So what I'm going to use is I'm going to use another module called PLT. Basically, it's matplot library. It is very, very useful library for drawing graphs, very advanced graphs. So import matplot.pyplot as PLT. So I'm going to name it. I'm going to name it PLT. And matplot inline. What this line of code does is actually shows the plots inside the outputs. In many cases, you don't need to type this line of code because Python or Jupyter Notebook automatically do it for you. But for the sake of assurance, we are going to execute this line of code as well. So later, I want to plot age versus salary. So I'm not going to use this library for now. Instead, I'm going to use actually an embedded function which is already available in the Python when you install it. So Python has actually this function as a default, so we don't need to call it. So df is my data file, plot is a module, and scatter is a function. So I want to ask Python to draw age versus salary, right? So there's a scatter, which shows age versus salary. As you see, this is a direct relation between these two. So another way for plotting is to use PLT. In that case, I need to define X and Y. So X is our age. So X is the variable age, which is located in data file df, and Y is the variable salary, which is located in the data file df. And then I'm going to use this function plt dot scatter X versus Y. So if you execute this one, we have got the same graph. So why I just use PLT, I wanted to show how to call this PLT because later on, for more advanced version of graphs, we need this file, we need this function even more. And then we want to actually run our regression to show if there is a impact, if there is a relationship, first of all, between age and salary, and if so, what is the coefficient, and if the coefficient is significant or not. So I'm going to use the package stats models API, which is very common and a famous package for running linear regressions in Python. Again, I just need to repeat myself several times. This is not the only way to run regression in Python. There are many other ways. So import statsmodel.api as SM. And the next step is to define our constant or intercept variable as well. So already we defined x is df_age, and I want to add the constant to age. So I'm defining uppercase x, which is sm dot add constant to x. X was age, remember here. And also I wanted to see uh, what I would have as x in the array of x, and what I would have in the array of y. So we run this code. So this is my x, This is basically cap x contains constant and x1, um, which is our main independent variable, and y is our dependent variable. Later, I wanted to run regression. So reg is equal to Sm. I'm going to use Sm again. This time I'm going to use the function OLS, all with cap, OLS y dot x, close bracket, dot fit. So fit is the function. I'm asking the Python to run regression for me and print the results, which is reg.summary, and you would have the results here. So as you see, if you want to interpret the result, the variable age coefficient is 3827, and it's significant because p-value is less than 0.05. So we can say that this coefficient is significant at the level of with the confidence level of 95%. And what else? The R square is 54. It means that the actual 54% of variation of dependent variable is explained by independent variable. And this is how we can run regression in uh, Python.